So, who records history? Okay.
Typically the winner.
Those of us that don't know history are doomed to repeat it. This is an old expression. But I want to know who records history in these different organisms. And the history I want them to record is the history of body water. And the reason I want them to record the history of body water is that it might tell me something about environmental water. The reason I want to know something about environmental water is it might tell me something about the environment. So I want to know what kinds of biomarkers are available. So biomarker is an expression we use in which we have a biological material that is recording some aspect of the environment. You'll hear that we have biomarkers that tell you about the water source. We have biomarkers that tell you something about your diet. We have biomarkers that tell me something about your travel history. So there are lots of biomarkers that you're going to hear. And the kinds of biomarkers that we might think about and talk about, some of these will be familiar to you, others won't. In plants, we have things such as cellulose, which is a biomarker. When it gets laid down in sequence, we call those tree rings. We have N-alkanes, which are waxes that you'll hear Brett Tipple talk about and Kate Freeman talk about. So these are waxes that tend not to be degraded over time. We have proteins. We can use proteins as a way of recording information. Animal systems add on to this. We've got nails, such as Christy will talk about. Christy's interested. Teeth, bones, hair. Terry will talk about hair, as you see. In microbial systems, we could do this in humans as well, but we have nucleic acids. A lot of people look at nucleic acids. They look at cell walls and proteins. Others look at things such as feathers and claws as a way of recording the protein that records. Others look at wings and carapaces. So there are lots of materials, virtually anything in an organism that records as an H and an O is going to record some aspect of the body water and some aspect of the environment. It's up to you to be clever to know these rules and to know that all these rules are very general applications. They are so general that we're going to spend a couple of lectures on this. And so you'll hear Turi spend a lecture on hair. So Turi's lecture on hair on Friday will tell you something about isotopic records. Next Tuesday, I think it's next Tuesday, I'll spend some time talking about forensic applications. You might use this in forensic cases closely involving humans. Kate Freeman will talk about this on the last day of class. In fact, your whole lecture will be focused on biomarkers of different kinds. John Roden will talk about this on Thursday. He'll talk about a particular biomarker called cellulose. So this is a very common approach. And what I just want to spend the last couple of minutes talking about are some things that we're not going to talk about, because I just think they're really cool. So I am a real fan of Jennifer Mallett. Jennifer Mallett was in a course a few years ago. She works for the Drug Enforcement Administration doing research, and they use stable isotopes to record where materials come from. In fact, they've been able to show that if you go into different parts of South America and collect coca samples, don't get too excited, and collect coca samples, that you can extract the cocaine without fractionation. And that the isotopic composition of carbon and nitrogen isotopes can be used for geolocation. And the isotopic composition of proteins can be predicted and used. So if you had a water isoscape of the kinds that Gabe described, and you knew the rules of fractionation, you could predict where a cocaine molecule had come from, what region. And so there are 19 known growth regions within South America. You see them at the top, and you see an isoscape map at the bottom. So this is not unique, but the combination of this and other isotopes begins to make it unique. And what I want you to see is that if you look at the relationship between hydrogen isotope on the y-axis and oxygen isotope on the left axis, that the value values do not fall on the near water line. In fact, they fall on what looks like a leaf water line with a slope of about 3.5, which is consistent with the humidity you find in those parts of the world. Suggesting that if I know what leaf water is and I know what the fractionation factor is, I can tell you where the paintings come from. And so what do they use this for? They seize cocaine from ships in the ocean. And their task is, where did this come from, to know where to have our interdiction effects. Very cool application. Happens to be not a protein molecule, but an alkaloid. Leslie Chesed, who will be speaking next week on food, is interested in the isotopic composition of proteins, such as food proteins. So again, we can plot hydrogen isotope on the y-axis and oxygen isotope ratio on the x-axis. We can look at beef, eggs, pork, freshwater fish, marine fish, bivalves, crustaceans, and for the most part, everybody falls on the same relationship. So if I'm eating a trout at the store tonight, or at the restaurant tonight, and I grab a little bit, I can tell you whether that trout came from a cold region, a warm region, just what the isotopic composition of the water was that that trout was cultivated in. Oh, I can see a forensics application here. I can see an anthropological application. I want to know something about trade routes. So lots and lots of very interesting applications. It turns out that looking at saltwater fish is absolutely boring. Why? There's no variation in the ocean. So you've got to get into a freshwater system. Something weird is happening when you begin to look at some of the marine bivalves. What Helen did was begin to tackle a case that was probably very important at the time we were kids, but not, people tend to forget it now. We had something called the anthrax attack, in which somebody mailed anthrax to people, including senators, and a few people died. The question is, where did the anthrax come from? Helen showed that you could use the stable isotope ratios and say something about the culture media. She then used this to say, oh, if I know the various places in the United States where that could have been cultivated, I can tell regions apart if the water isotope's different. And I might be able to help pinpoint your investigation to show where the anthrax had come from. So we are still under a non-disclosure agreement. So I can just say, she got it. She got the right place. She was able to identify what lab did it come from, and more important, she was able to identify what food source the microbes have been growing based on CN and SI. What I want to end up with is, I think, a really cool one, because a lot of people are interested in birds and bird migration. And bird feathers are protein. They're keratin, just like hair and fingernails. And they record location because the isotopic composition of a bird feather is related to the isotopic composition of environmental water at the time a feather was formed. Oh, now I can say something about resting areas and breeding areas by looking at the isotopic composition of different feathers. Absolutely cool. And there was a real important application of this. You guys might have seen the movie Sully. How many of you saw the movie Sully? Okay, a couple of you. So this is the Miracle on the Hudson. Plane takes off from New York. As soon as it gets in the air, it comes in, runs into a flock of Canada goose, brings the plane down. This guy miraculously lands the plane in the Hudson, and every single person gets off the plane alive. So the question becomes, where did those Canada goose come from? And this has huge implications. We have something called a shotgun program in the United States around airports, in which we randomly shoot off shotguns to keep the birds away. Okay. If the birds had been from New York, there was a residential population, we would have have had a huge, huge increase in the number of shotgun programs at all airports around the United States. So they pulled the feathers out, measured the isotope ratios. They know the isotope ratios of birds from the New York area. And lo and behold, the birds are not from New York. They're from Newfoundland. So we were looking at a migratory population. So there's nothing they could do about a migratory population, so it did not result in a change. But this is an application where people wanted to take the basic science that you've done. You might be interested in migratory routes, but now to apply it. Does this have any implication on policy and procedure? So all these are implications of how you might use body water reported in molecules for different applications. So I'll just stop and ask if there are any questions. Yes, ma'am. And you have to tell me your name because I can't see it.
Stephanie.
Stephanie, okay.
For the plant water, or I guess in general, has there been much research done on fungal water isotopes?
What?
Fungal water?
So that is a superb question. Are there studies looking at fungal water? There is a paper that has just come out by the group at Penn State on a review to suggest that the two different fungal groups, one might be associated with water uptake from micropores, the other not. I can get you that literature. But there is a suggestion that in some cases that fungal hyphae are used in water extraction, sort of to extend what root hair cannot get.
Okay.
I think it's for one group of mycorrhizal, but not the other.
Okay.
Any other questions? Okay, well, thank you guys very much.